Waveguide Junctions E Plaintiffs series on microwave engineering, lecture number 1.14. E Plaintiffs are a type of microwave junctions. Like any other microwave junction, these junctions are also used either to split or to combine waves. E Plaintiffs have 3 ports. Hence, they can split a wave into 2 parts, or they can combine 2 waves into 1. The use of this device and other microwave junctions too is mostly to split the wave, to divide the wave. Like other microwave junctions, E Plaintiffs are linear, they are passive too. They can be fabricated either with coaxial line pieces or with rectangular waveguide pieces. In the present session, the discussion is concentrated on E Plaintiffs which are fabricated with the pieces of rectangular waveguides. Now we move to the core session to have a deeper understanding regarding the structure and functioning of E Plaintiffs. As introductory statements, a few points are given here. They are: E Plaintiff is a 3-port, 3-arm microwave junction. There exist 3 openings in the device. That's why it is 3-port device. It consists of 3 arms. It is used at microwave frequencies. It is basically a junction. Junction means a device capable of dividing or splitting a wave and also combining waves. These are also called series junctions. These are also called voltage junctions. Like any other junction, these are used either to split a wave into 2 or more parts, or to combine 2 or more power streams into 1. Note, E Plaintiff output is 2 waves. It can take 2 waves as inputs when it is working as a combiner. So it is basically 1 to 2 or 2 to 1 device. These are passive devices. They can be made either with coaxial cable sections or with rectangular waveguide pieces. The discussion here is focused on waveguide version of E Plaintiffs. To fabricate a E Plaintiff from waveguides, 2 pieces of waveguides are required. An aperture is made in the middle of top border wall of one piece, and the second piece is connected enclosing the aperture. It is like this. This is one piece. Rectangular waveguide consists of 2 border walls, bottom border wall and top border wall. In the top border wall, make an aperture or slot like this. Remove the metal from this part. Now it is a hole here. Now connect another piece to this waveguide, and the connection should be such that the second piece must cover the entire slot made in the border wall. The resultant structure now is E Plaintiff. We can easily notice 3 arms in the structure of this device. This is 1 arm, 2nd arm. These 2 arms are in line, so they are called collinear arms. And the 3rd arm, which is attached to the guide piece, which is now split into 2 collinear arms. So 3 arms are there in the structure. 3 openings are also there. This is 1 opening, another opening, whereas the side arm has the opening, side arm opening. Technical name or scientific name to opening is port. So it is a 3-port, 3-arm device. Here various features, physical as well as electrical, of the device are illustrated in diagrams, 4 diagrams, A, B, C, D. The structure is clearly given in A. 2 collinear arms, 1 side arm, Side arm here is also called E arm. E here stands for electric field vector. When wave is there in a rectangular waveguide in dominant mode, in the wave, the electric vector is always vertical. It is normal to broader walls. It is parallel to narrow walls. Any vertical plane parallel to narrow walls is called E plane. The side arm is in E plane. That is why this particular junction device is called E plane T. And as the side arm is in E plane, it is called E arm. In this diagram, one can see the port numbering also. Collinear arm ports are usually given numbers 1 and 2. Side arm port is given number 3. Port numbering is an important aspect in the study of multi-port microwave junctions. In B, the fields inside E plane T, they are given through flux line representation. Let us suppose source is connected to port 3. Then source drives a wave into the side arm, and if the wave is in a dominant mode, electric vector in that wave will be from one broader wall to another broader wall, parallel to side walls. It may be left to right or right to left, but here in the diagram, electric vector is shown from left to right. Notice it is wave. If the electric vector is left to right in one half cycle, in the next half cycle, it will be in the opposite direction, from right to left. Here in this diagram, an instant is considered where electric vector is from left to right in the side arm port. Then what is the electric vector in different parts of the device? It is shown here in side arm 1, or the arm which has port 1. On that side, in that arm, electric field is shown pointing downwards. Whereas in side arm 2, or arm which has port 2, there in that arm, electric vector is shown pointing upwards. What is the reason? In electric vector having different directions, opposite directions in collinear arms. To understand this aspect, let us say the broader wall on port 1 side, let us designate it as A, and the broader wall which is the left side in the side arm, let us designate it as B. Notice A and B are in connection. A and B are made with good conductors and they are in contact with each other. Because of this reason, if electric vector originates from wall B, it has to originate from wall A too. If electric vector terminates over wall B, it has to terminate over wall A too. This aspect has to be kept in mind while sketching the flux lines inside the device. Same reasoning, same argument can be applied to walls. Broader wall, upper broader wall on collinear arm 2 and right wall on side arm. Let us call them X, Y. X and Y are in contact. Therefore, the electric vector must terminate on both, or it must originate from both. Keeping these aspects, now sketching flux lines when wave is there in the device, it is not at all difficult. One observation can be made before going to the next diagram. When input is given at port 3, output appears at port 1, at port 2. At port 1, electric field is looking downwards. At port 2, it is looking upwards. It implies the outputs are out of phase. In C is shown the symbol, a straight line, a vertical line. Vertical line denotes side arm or E arm, whereas straight horizontal line represents collinear arms. An equivalent circuit of E plenty is shown in D. It consists of two transmission line pieces. So the equivalent circuit here is in terms of transmission line pieces. That's why it is called transmission line equivalent of E plenty. By noticing the connection between side arm and collinear arms here in the junction region, one can understand why it is called a series junction. Some more points regarding E plenties. Out of the three, two arms are inline and the third one is looking upwards. The inline two arms usually equal in length. They are called collinear arms, whereas the other arm is called side arm or E arm or series arm. As their side arm is in the E plane, these are called E plenties. Usually, collinear arm ports are designated as 1 and 2 and side arm port as 3. There are two properties which are required to be kept in mind, which are required to be taken, to be considered as significant properties of E plenty. What are they? First one is port 3 is perfectly matched to the junction. What does it mean? This is E plenty. Port 3 means side arm port, this one. Port 3 perfectly matched to the junction means if you give a wave at port 3 which travels towards the junction and it gets absorbed completely in the junction region without any reflections back towards the source. Of course, in the junction region, the wave gets split into two parts. One part moving towards one collinear arm port and another part moving towards another collinear arm port. But no wave exists towards the source or port 3. No reflected wave exists towards port 3. That's why port 3 is said to be perfectly matched to the junction. Second property worth remembering is ports 1 and 2 are electrically anti-symmetrical with respect to port 3 when its collinear arm lengths are same. What is the meaning of electrical anti-symmetry? Once again, consider a wave input at port 3, side arm port. This wave enters into the junction region. There it gets split into two parts. One part reaching one collinear arm port, another part reaching another collinear arm port. So two waves appear, one at port 1, another at port 2. Anti-symmetry means these waves are out of phase. Waves at ports 1 and 2, output waves, they remain out of phase. The functioning of these devices can be expressed in terms of a set of line sections, which then is called transmission line equivalent of the device. Equivalent circuits are widely used in different subjects of engineering. They are highly useful both for understanding the functioning of the device as well for the analysis of the device to find its response. Here also, transmission line equivalents are useful in understanding as well as in the analysis of the device. As already mentioned, primary use of E plenties, for that matter, any junction devices, to divide a wave into two or more. In E plenties, one can divide the power only into two streams. One can divide the wave into two waves only. How it works? How it is able to divide a wave into two? This aspect is described with the help of block diagrams. 4 diagrams are given: A, B, C, D. A, B describes wave division in terms of amplitudes, whereas C and D describes division of wave in terms of powers. Consider A. Usually, source is connected to side arm port, port 3. Let us suppose amplitude of the wave in side arm is A. This wave enters into the junction region without any reflections back towards the source. After entering into the junction region, it gets split into two parts, for that matter, equal parts. One part moving towards port 2, another part moving towards port 1. The amplitudes of these two waves are same and equal to A by root 2. In B is shown an arrangement where source is connected to one of the collinear arm ports. Port 1 here is connected with a matched source. In such case, how the division is made, how the wave is split, how the device functions as a wave splitter. It is explained, it is described here in terms of amplitudes, wave amplitude. Let us suppose amplitude of wave driven into collinear arm 1 is A. This wave then travels towards the junction, and after reaching the junction region, it enters into the junction partly, and partly it gets reflected back towards the source. The wave that entered into the junction region, it gets split into two parts, one part moving towards port 2, another part traveling towards port 3. A little bit of analysis tells us that amplitudes of the waves moving towards 1, 2, 3 are A by 2, A by 2, A by root 2 respectively. Now let us move to C and D, where the functioning of E plane T is described in terms of powers when it is working as a divider. In C, source is connected at port 3. Let us suppose power in the wave that is driven into side arm is P. Then this wave completely, totally enters into the junction region. It gets split into two parts, one part moving to one collinear arm port, another part traveling to another collinear arm port. The powers in these two waves, they are equal, same, and it is equal to P by 2. In D is illustrated when source is connected to one of the collinear arm ports, port 1. Here it is assumed that the source output into collinear arm is P. The wave out of the source then enters into the junction region partly it gets reflected. The wave that entered into the junction region, it gets split into two parts, one part towards another collinear arm port, one part towards side arm port. The powers that are traveling to ports 1, 2, 3 are P by 4, P by 4 and P by 2 respectively. Before going further, notice the fact that E plane T, it is capable of dividing wave into two. It is capable of working as a perfect splitter only when the source is connected to side arm port. When the source is matched, the total wave, total output of the source, it is accepted by the junction and it is divided into two equal parts. It happens only when the source is connected to side arm port. If the side arm port is not used to input, if one of the other two ports, collinear arm ports, is used for input, then reflection happens towards the source. Then it is no more a perfect division. The functioning of the device as divider is now explained in words in more exact terms. If the amplitude of the input wave at port 3 is A, then amplitudes of the waves at port 1 and 2 are same and equal to A by root 2. The waves at the output ports are out of phase when its collinear arm lengths are same or differ by integral number of wavelengths. They are in phase if the collinear arm lengths differ by an odd number of half wavelengths. Most commonly, the collinear arm lengths are same. Just for giving an understanding, just for giving an insight into the functioning of the device, just to give a feel regarding the physics of the device, these points, these aspects like differ by integral number of wavelengths, differ by odd number of wavelengths, these aspects are mentioned. Otherwise, the device is always with same collinear arm lengths. Some are points regarding the functioning of E plane T as divider. If the amplitude of input wave at one of the side arm ports, let us say port 1 is A, then amplitudes of the waves scattered by the junction into 1 and 2 are same, equal to A by 2. At port 3, the wave amplitude is A by root 2. When the power incident at port 3 is P, then powers that appear at ports 1 and 2 is P by 2 each. For this reason, the device is being called 3 dB splitter. Notice E plane T is a 3 dB splitter. It means the input power is divided into two equal halves. There is no provision in this device to divide power other than half. Suppose I want to divide the input power into, let us say, 2 by 3, 1 by 3 ratio. In this device, there is no such provision. The division is always 50-50. If the power incident at one of the side arm ports, let us say port 1 is P, then the power scattered by the junction into ports 1 and 2 is P by 4 each. And at port 3, it is P by 2. Now we move to a discussion on action of E plane T as wave combiner. In the typical application of E plane T as combiner, the sources of the waves are connected to collinear arm ports. Output is taken from side arm port 3. It is illustrated in diagram A. One matched source connected at port 1, another matched source at port 2. The device is supposed to combine the outputs of these two sources and submit it to matched load connected at port 3. If we suppose amplitude of the source connected to port 1 is A and amplitude of source connected to port 2 is also A, then when it is functioning as combiner, one wave will be traveling towards matched load whose amplitude is A. Two waves will be traveling towards collinear arm ports, each wave with an amplitude equal to A by root 2. So in the functioning as combiner, one can notice there are reflected waves traveling towards the source. When these waves enter into the sources, there is a possibility of causing a disturbance in the functioning of the sources. So it is not a happy situation. In B, the functioning of E plane T as combiner is described in terms of powers. Let us suppose the sources connected at port 1, port 2, their outputs is the same and equal to P. While it is functioning, three waves exist, one wave towards port 3, two waves towards port 1 and 2. Waves towards ports 1 and 2, they have same amplitude equal to P by 2. Powers equal to P by 2. The wave that is traveling towards port 3, its power is equal to P. Here some conditions are being mentioned. It is assumed that collinear arm lengths are same and the sources are out of phase. Here, this diagram, these numbers, for their validity, these conditions are to be met by the sources. Some more description of E plane T as combiner in words. When equal strength A input signals are given at both the collinear ports, the output that appears at the sidearm port has an amplitude A with power equal to one of the input sources powers. Here it is assumed the collinear arm lengths same and sources are out of phase. The power out of third port is 0 and no power flow exists in any part of the device when two equal strength and in-phase sources are connected to collinear arm ports and collinear arm lengths are same. This is similar to two equal but out-of-phase sources connected in parallel driving a transmission line. One source nullifies the other, leaving no driving force at all across the line. These E Plaintiffs, they are in use at several places in microwave communication systems, both in transmitters as well as in receivers. A few applications, primary applications, main applications, they are being mentioned here. They are used as tuners. Tuners are circuits which are used mainly to change the frequency in kilohertz range, in megahertz range. Circuits, a gang capacitor can be used for tuning, for frequency tuning. But at microwaves, capacitors, gang capacitors, they don't work. Waveguides are used. They are used also as dividers and adders. About this aspect, we have already discussed. We have spent already good amount of time. Now there is no need for any further elaboration. These are also used in duplexer assemblies. These duplexer assemblies, they are used in radar systems. Radar systems are communication systems. They have a transmitter, they have a receiver. Transmitter is connected to an antenna, receiver is connected to another antenna. So in a typical radar system, there exists two antennas. Typical radar installations require two antennas, but duplexer assemblies make one antenna redundant. They give the capability to radar to function with one antenna. Naturally, system with one antenna is less expensive when compared to system with two antennas. Therefore, E Plaintiffs are part of duplexer assemblies which can make radar systems less expensive. So their application in radar systems is a critical as well as a beneficial one. These are the things what I have to share with you for right now. To recap, E Plaintiffs are introduced giving their physical features and electrical characteristics. An in-depth explanation is given regarding their functioning as dividers and combiners. A small brief is also given regarding their applications. Hope you have a beautiful and wonderful, a fruitful and successful, a useful, enriching learning experience. See you again soon. Bye bye.